Please be back to our meeting room. We will continue our work, our class. Okay. Please be back to our meeting room. Okay, thank you very much. So we will continue, and so we will continue the record. Okay. So we'll start the work and the power and efficiency. Okay, let's play this. Okay, so record. Okay, power and efficiency, and we already know the work. We know the energy, kinetic energy. We know the work and energy equation, and we apply the work and energy equation to find out the velocity. And we will continue to know the power. Power is defined as the amount of work performed per unit of time. Here, power is actually work per unit time. And this one, we will know it often in hydraulics. Okay, if a machine or engine performs a certain amount of work, du, within a given time interval dt, then the power can be calculated as du dt is according to the calculus, right? And since the work can be expressed as du equal to f dot dr, what does it mean? U, this is the element work, right? And then element work will equal to the force times the element displacement. Sorry. This will be the element displacement. So the element work will equal to the force dot the displacement. Then the power, we calculate the power as the power, we use the capital P to indicate the power. P is actually work per unit time equal to F dot dr. And we know for element, so dr dt will be the velocity. So we know for the power actually is equal to the force dot the velocity. It's a scalar. Okay, it's a scalar because dot product always resulting a scalar. It can be positive, it can be negative, right? Yeah, if the okay, actually powers here is always be positive because the product of the force and velocity components acting in the same direction. Okay. Sure, for the according to the definition, power is actually equal to the magnitude of the force times the velocity times the cosine theta, where theta is the angle between the force and the velocity vectors. Again, if the force is perpendicular to the velocity, the power will equal to 0. Okay, so zero power in the SI system will be the watt, and here 1 watt is equal to 1 Newton meter per second. This is a unit for the work, right? Work per unit time. In the FPS system, sometimes we would like to express the power in units of horsepower, HP. Okay, this HP means horsepower. Okay, equal to here. So you can transfer the the units of SI system to the FPS system. Okay, so after we have know the power, we should know the efficiency because the mechanical, sometimes not all the input power have been used. So the mechanical efficiency of a machine is the ratio of the useful power produced, output power, to the power supplied to the machine, input power, or the efficiency is equal to power output divided by power input. Later on in the course of hydrostatics, we will know the efficiency. Often we will try to calculate the efficiency of a pump, of a turbine, just like the power provided by the turbine. Part of them are transferred to the energy of the water. So only part of the power provided by the pump is used. Okay, so that means the output power actually is smaller than input power. So the ratio will be called the efficiency. Okay, if energy input and removal occur at the same time, efficiency may also be expressed in terms of the ratio of the output energy to input energy, just like here. Output energy, input energy. Machine will always have frictional forces. Since frictional forces dissipate energy, additional power will be required to overcome these forces. So that's why the efficiency of a machine will be always smaller than one, will be always less than one. Okay, not all the power provided by the machine will be really used. Okay, some of them will be wasted, just like the friction forces. Okay, just friction loss. Okay, how to find out the power, how to find out the efficiency. We still have the procedures to follow up. Okay, first we need to find the resultant external forces acting on the body holding its motion. And so it is necessary to draw a FBD. We need to know how many forces, what kind of forces on the particle or on the particle of system. Okay, and again, only the external forces are important because the internal forces between particles will cancel out with each other. And then if we need to find out the power, we not only need to know the force, but we also need to know the velocity. We need to know the velocity of the point on the body at which the force is applied. Okay, it should be simultaneous force and the velocity. Okay, so then you need the knowledge of the kinematics. That's why we always say when you solve a problem of kinetics, you need knowledge of FBD, force analysis, also need knowledge of kinematics. You need to know the velocity, you need to know the acceleration, you need to know the relationship between velocities of blocks, you need to know the relationship between the acceleration of blocks, right? Also the displacement relationship, just the one example we have solved together. And then after you find out the force, after you find out the velocity, it will be easy to calculate to find out the power because we only need to multiply the force magnitude times velocity in the same direction. Okay, again, it's dot product. Okay, power is equal to the force dot velocity should be very important. Okay, should be dot product. Okay. So if the force is perpendicular to the velocity, there will be no power. Yeah, this is should be easy to understood, right? Just like if the force is perpendicular to the displacement, there will be no work, and so power is actually work per unit time. No work, no power. Okay. Sometimes power may be found by calculating the work done by unit of time. That means if you find out the work is a function of time, so we can take the first time derivative of the work to find out the power. And furthermore, if the mechanical efficiency of a machine is given, so either the power input or output can be determined, right? Because we know the mechanical efficiency is actually the ratio of the output power over the input power. So If we know the efficiency, we can find out the input power or the output power. It depends on the question. It depends on whether we need to find out the input or output power. Okay, just like here for a car, this is a sports car. A sports car has a mass of 2 mg and an energy efficiency of 0.65. The efficiency is given. Okay, the efficiency is output power over the input power. Okay. Moving forward, the wind creates a drag resistance on the car of Fd is equal to the 1.2 V square Newton. What does it mean? When you drive a car, there will be resistance on the car by the wind. Okay. And then we know the drag force will be a function of the velocity. Okay. And the car accelerates at 5 meters per second square starting from west. That means we know its acceleration. The acceleration is constant and it starts from west. And then we can know its velocity at any time. We need to find the input power when t equal to 4 meter. We need to find out the input power, and here we have the efficiency. So if we know the output power, we mean the power to drive the car, we can find out the input power, right? Because the efficiency is equal to the output power divided by the input power. So if we want to find out the input power, we need to know the output power. The output power is actually equal to the F dot velocity. So we need to know the velocity, right? We need to know the velocity. The velocity is easy to find out because the car acceleration is given is a constant and it starts from west. So we can find out the velocity at t equal to 4 seconds. And then we need to find out the F. So the F, so for the car, which force actually drive the car? Can you tell me which force can actually which force is responsible for the car to move? The friction force between the gears and the ground. If there is no friction force, there will be no moving, right? If you drive the car on the ice, it's very difficult to move forward. Okay, so we need to find out the power. So we need to find out the velocity. It's easy because the acceleration is a constant and given. And also we need to find out the friction force between the gears and the ground. Okay, how to find out the friction force on the car? So we need to draw FBD, right? So for the car, so for the car, we need to draw the FBD. The car will definitely the weight. This will be the weight, the normal force, the friction force, and the drag force by the wind. Right. Actually, here the drag force, we will learn this in the hydraulics, and we know that in the design of the car, the fluid mechanic engineers really have done a lot of work to improve the efficiency of the car. Okay, so to reduce the drag force, that's how we improve the efficiency one way. Okay, so this will be the FBD, and according to the FBD, we can apply the equation of motion. Why? Because the acceleration is given, right? So accordingly, in horizontal direction, if we define to the left as a positive, it's up to you. You can define to the right as a positive. Okay, so to the left as positive because the friction force is actually the driving force. So we have in x direction Fc, the friction force, or we say it's actually the driving force. This one will be the FD, the drag force. Okay, and well equal to max. Ax is giving, and the acceleration is giving, right? And here you say because driving force Fc or the friction force Fc is here is giving because the drag force by the wind is a function of the velocity. So we need to find out the velocity when t equal to 4 seconds. How to find out the velocity? As we said, because it's a constant acceleration, so quite easy. Because we know dv dt is equal to the acceleration. Acceleration is a constant, so it's easy to find the velocity. The velocity at any time will equal to the initial velocity plus axt. So it's 20 meter per second. So accordingly, we can find the friction force when t equal to 4 seconds, right? Just substitute the velocity, the value of the velocity to this equation. We can find out the Fc, right? And then the power output of the car, I mean, the output power is actually to drive the car. It will be equal to the friction force times the car velocity, because the friction force and car velocity actually are collinear. Okay, so we have the power output power. That means the power have been used. Okay, we calculate this, and some power are used and some are waste. And because the efficiency is not equal to 1, the efficiency is equal to 0.5. So the input power should be the output power divided by the efficiency. We can find out the input power. Okay, so here to find out the input power, just like, okay, we just review this again. Okay, here you need to find the input power. Let's find out this. You need to find out input power. The efficiency is given, so we need to find out output power. We need to find out output power. We need to find out the friction force. We need to find out the velocity, right? Because power is equal to the friction force times the velocity. They are collinear, okay? And the velocity, we need to find the velocity because the acceleration is given. So we can find the velocity at any time, okay? Because the velocity at any time is equal to the initial velocity plus acceleration times the time elapsed, okay, the elapsed time. And also for the FC, we need to use the FBD. We use FBD, and then we write down the equation of motion. The equation of motion to find out FC. Okay, so then we can find out the input power. So this is logics. Okay. Also, because some of you say, it's okay for me to understand what you are talking about, but I can't do it by myself. So every time when you need to find out, when you need to solve the problem, you need to ask yourself, if you need to find out this answer, what you need, and then just do this step by step, and you can figure out, okay. So the power supplied by a machine will always be less than, equal to, greater than, or A or B. Which one? It's very simple. It's very simple. The power supplied by a machine will always be which one power supplied by our machine will always be less than the power supplied to the machine. So the power supplied by a machine is the output power. The power supplied to the machine will be input power. So it will be always less than. That means the efficiency will be always less than 1 because there will be loss by the friction force. Okay. Yes, thank you very much. The answer should be A. A car is traveling a level road at 88 uh, feet per second. The velocity is given. The power being supplied to the wheels is given. Find the combined friction force on the tires. Again, the friction forces. Okay, the friction forces actually provide the power. So which one? Yeah, it's 600. Okay. Just the mathematics, simple. Okay, so answer should be C. Thank you very much. Okay, really appreciate your response. Okay, so after we have learned about the work, kinetic energy, power, we will continue to study conservative force and potential energy. Okay, so what's conservative force? Why we call it a conservative force? Okay, a force F is said to be conservative if the work done is independent of the path followed by the force acting on a particle as it moves from A to B. Here, the work is independent of the path. So you can just recall what kind of force we have learned. The work by the force is independent of the path. Okay. First, weight, right? The weight will be the work done by the weight will be independent of the path. Okay. So in other words, the work done by the force F in a closed path from A to B and then back to A will be equal to 0. That means just like you climb the stairs and then you come downstairs, no work by the weight because you have been back to the same position, the initial position. Okay, so here because the work done by the force is equal to 0. So that means the work is conserved. That's why we call the conservative force. Okay. So accordingly, because the conservative force is independent of the path, so a conservative force depends only on the position because a conservative force depends only on the position of the particle and is independent of its velocity or acceleration. Sure, we will have more vigorous definition of a conservative force in terms of mathematics, but we just don't need to give that to study the exact mathematical definition of conservative force. Here for us, we just know that the conservative force we have learned. One is gravity force or the weight. We know the weight is independent of its path. Whether you take the lift or you go downstairs on foot, actually the weight have done the same work to you. Okay, the weight is only depend on the vertical displacement. Okay, and then the spring force. When we calculate the here the spring force we only talk about the linear spring force. Okay, the spring force only the initial and the final stretch length uh, uh, related to the work by the spring, okay, force. So gravity force, spring force, they are conservative force. So we have the potential energy. What means potential energy? Potential energy actually is to measure the amount of work conservative force will do when it changes position. So potential energy is to measure the amount of work by a conservative force. So generally speaking, for any conservative force system, we can define the potential function as a function of position. Why? Because the work done by the conservative force is only a function of position. So potential energy is also only a function of position. The work done by conservative forces when the particle moves equals the change in the value of the potential function, right? The sum of gravity and the potential energy and the potential energy of spring force. And we need to be quite familiar with the two types of potential energy. We mean the potential energy by the gravity force, by the spring force, and we need to calculate the magnitude. Okay, here the potential energy due to gravity. Okay, the potential function for gravitational force, for example, the weight, because the weight is equal to mass times the gravity acceleration. It's the force multiplied by its elevation from a datum. The datum can be defined as at any convenient location. It's very important here. The datum line can be defined. Yes, at your convenience. It's up to you. You can define any line as a datum line. And then the potential energy will equal to the weight times the vertical distance to the datum line. It can be positive, can be negative here. So when it's above the datum line, so the potential energy by the gravity force will be positive, or it will be negative. Okay. So when it's at datum line, the potential energy of the gravity force will equal to 0. Okay. The potential energy is actually is a measure of the work by the conservative force, just like here by the gravity force. Okay, so we need to calculate, we need to know how to calculate the potential energy. Okay. So when you write down the potential energy, that means you already have set up, have established the datum line. So first thing to define the datum line for the gravity force, for the potential energy of the gravity force, and then you can calculate, you can find out the potential energy by the gravity force. We use big V and the subscript G gravity force to indicate the potential energy of the gravity force. Okay. W is the weight of the particle or the rigid body. Okay. For spring force, because here for linear spring force, the force is equal to Ks. K is actually the stiffness coefficient. S is the displacement referred to the unstretched position. Again, here S, we need to pay attention. Okay, so here S is unstretched position referred to the unstretched position. Okay, it is important to realize that the potential energy of spring, while it looks familiar, is a different formula. V E, we use big V to indicate its potential energy, the subscript E to indicate the elastic spring has a distance S. Distance S here, the distance S means refer to the unstretched position, measured from the unstretched position. Actually, the unstretched position just works like the datum line for the potential energy of the gravity force. Okay, and then the VE, the potential energy of the elastic force, will equal to 1/2 K is actually the stiffness coefficient. S is actually distance, the distance measured from the straight position square. Okay, and so for the potential energy of the elastic spring will be always positive. Okay, so no matter it's compressed or it's put, it the potential energy of the spring force, the elastic potential energy will be always positive because here is S squared. Okay. So energy is conserved. Why we say energy is conserved? How we say energy is conserved? One particle is acted upon by a system of conservative forces. We mean just like the gravity, like the swing forces. Then the work done by these forces is conserved, and the sum of kinetic energy and potential energy will be always unchanged. That means the sum of the kinetic energy plus the potential energy remains constant. That means as the particle moves, kinetic energy is converted to potential energy and vice versa. Okay, there is no energy loss. Okay, this principle is called the principle of conservation of energy, and it's expressed as T1 plus V1 equal to T2 plus V2 equal to constant. Okay, here T1 is actually the initial kinetic energy. V1 is actually the initial potential energy function. Here, if there are spring force and gravity force involved, you need to account for them both. Okay, the potential energy. And T2 plus V2, T2 will be the kinetic energy at position 2, V2 will be the potential energy at position 2. Okay, so sure, definitely, yeah. For the energy, for the conservation of energy, you can use this one. Also, you can use the work and energy equation. It will result in the same answer. Okay. You can just use T1, the initial kinetic energy, plus the work done by the gravity force and the spring force will equal to the kinetic energy at position 2. Or you can use the conservation of energy equation just like here. The kinetic energy, or we call the total energy. The total energy is equal to the kinetic energy plus the potential energy will be always a constant when the particle moves. Why? Because they are only conservative forces that done work to the particle. Okay. For example, here, the girl and the bicycle weigh 125 pounds. She moves from point A to B. We need to find out the velocity and the normal force at B. If the velocity at A is given is 10 feet per second and she stops pedaling at A. She stops pedaling at A. What does that mean? It means that there will be no input energy by the girl. So when it drives down, to position B, only weight. Here we ignore us. Here we don't consider the friction force. That means there is no friction force. Okay, so only weight will do. Only weight have done work to the girl when it moves from point A to B. So that means only conservative force. How can I just make such conclusion? Because I draw FBD, right? For FBD, so the force on the girl will be the weight and the normal force, right? There will be no friction force, okay? And then when it drives down, we drive downward, okay? So the normal force is always perpendicular to the displacement. So no work done by the normal force. Only the weight, okay, have done work to the girl. And we know gravity force is actually a conservative force. So that means the energy should be conserved. That means when TA plus VA will equal to TB plus VB, right? TA, okay, TA and TB. TA is giving, right? Because the velocity at A is giving. So the energy, the potential energy, yeah, the potential energy is also giving, right? Because we can define this as data line. So the weight is giving, the height is giving, so the potential energy is also given. At TB, the potential energy is given, right? This is given, this is given, so we can find the, this is given, we can find out the kinetic energy at position 2, so we can find out VB, okay? We can find out VB, but how can we find the normal force? We need to use equation of motion. Just remind yourself, keep in mind, when you need to find out the force, you always need to use the equation of motion. Because when you use equation of motion, there will be the force analysis, the force related to related to the acceleration. But how do we know the acceleration at for the girl at point B? Because the girl has a circular path, so we use the anti-coordinates, right? We have the normal acceleration and tangential acceleration. And for normal acceleration, we know is actually is a function of the velocity. When the velocity is given, the normal acceleration is given. So normal acceleration given, and we can draw FBD. We know it will be the weight and will be the normal force. So we can apply the equation of motion in normal direction. We can find out the normal force, right? So it's not difficult, right? We can use conservation of energy, or we can apply the work and energy equation. Okay, so we just go through this again, okay, together. So first, after we draw FBD, we know that only the weight, only the gravity force have done work to the girl when it drove downward, because the normal force is always perpendicular to the displacement. So no work by the normal force. That means only the conservative force have done work. So accordingly, the energy is conserved. We can use conservation of energy. So the kinetic energy plus the potential energy at position A will equal to the kinetic energy plus the potential energy at position B. Because the velocity at position A is given, this one is given. So this kinetic energy at the position A is given. The potential energy at the position A is actually also can be calculated, because after we have defined the data line, the height of the girl is given. So we can calculate the potential energy. And then when it has the position B, its potential energy, because it's data line, so this one is equal to 0. So only all the energy transfer to the kinetic energy. Okay, so we have only VB is unknown. Okay, and one scalar equation, one unknown, we can find out VB. After we find out VB, we need to find out the normal force. What we can do, we can use the equation of motion. Okay, we can apply equation of motion. You see, this is FBD. It's quite simple. Okay, the normal force, the weight, and then we have the equation of motion in normal direction. Sigma Fn equal to MAN. AN, no, normal acceleration, because here the girl have a circular path, right? The girl had just circular path. So generally speaking, for this case, have a circular path, we can use anti-coordinates system. So AN, AT. Here we don't need to find out tangential acceleration. We only need to find out normal acceleration, okay? Because here, the normal acceleration is actually a function of the velocity, and the velocity is given, and the curvature radius is also given. So this one is given, and then we can find out the normal force, okay, at position B. The mass of the corner is 2 kg and the spring constant. Sorry, we go back to this. So definitely for this one, you can use the equation of work and energy. So what will be? T1 plus sigma, the work from 1 to 2 equal to T2, right? The initial the collected energy at position A plus the work down to the girl from position A to position B and equal to the kinetic energy at position B. You can solve this. Again, you will have the same results, okay? So here, one more example. The mass of the corner is 2 kg and the spring constant is 60 Newton per second. The corner has no velocity at A and spring is undeformed at A. Is undeformed at A. You need to find the maximum distance y the corner drops before it stops at point C. What does it mean? At the initial time, the block, okay, so all the corner, okay, just at position A has no velocity. That means VA equal to 0. So for the corner, TA equal to 0. And the spring is undeformed at A. That means the spring is stretched at A. Okay. And then we need to find the maximum distance. Why the corner drops before it stops at point C? What means it stops at point C? That means the VC equal to 0, right? The velocity of corner is equal to 0. And so from position A to position C, what forces on the corner have done work to the corner? Draw FBD. For the corner, weight, right? And normal force and spring force, right? Normal force, this will be the spring force. This will be the normal force. And weight, because we ignore the friction force here, we don't say we need to consider the friction force. Sure, generally there will be friction force, but here we don't need to consider the friction force. So from position A to position B, only the weight and spring force have done work to the corner. That means only conservative forces did works. So the energy should be conserved, right? So this one should be very simple. Okay, just do this and then submit online. I need you to work out this problem with two methods, two approaches. One is apply conservative energy equation. Okay, you need to first you need to use conservative of energy. Okay, and Also, you may use the work and energy equation, just like T1 plus sigma, the work done by the forces equal to T2, and to check out whether they will produce the same results. Okay, you need to solve this. Use two methods. One, you need to apply the conservation of energy. When you apply the conservation of energy, never forget to define the daytime line. Okay. Or you need to use the equation of work and energy. Okay. To do both. Okay. Thank you. Just after finishes, submit online, and then you can leave the meeting room. Okay.